Venus looks like Earth. Same size, same mass. From a distance, it should have been a second home, but it's not. What happened here shouldn't have happened because something went wrong. Not suddenly, not violently, but slowly, until this planet turned into a world where the surface is hot enough to melt metal, where the pressure can crush a human instantly, and where the sky rains acid. And yet, by everything we understand about planets, Venus should not exist like this, which raises a question scientists still can't fully answer. What went wrong on Venus?
For centuries, Venus was nothing more than a bright light in the sky, a wandering star, always hidden behind a thick veil of clouds. Even with powerful telescopes, no one could see its surface. No oceans, no continents, no detail. Just a smooth, glowing disk. And that mystery led to something interesting. For a long time, scientists believed Venus might be covered in oceans. Some imagined vast tropical seas. Others thought it could be a swamp-like world, warm and wet, possibly even supporting life. It wasn't a crazy idea. After all, Venus is Earth's closest twin in size and structure. Same type of planet, similar gravity, similar composition. If Earth could support life, why not Venus? That idea survived for decades, until we finally went there. In the 1960s and 70s, a series of spacecraft were sent toward Venus. Many of them failed, crushed, melted, lost in the atmosphere. But a few made it. The Soviet Venera missions were the first to survive long enough to send back data from the surface. What they revealed changed everything. The surface of Venus was not an ocean, not even close. It was dry, rocky, and unimaginably hot. Temperatures hovered around 460 degrees Celsius, hot enough to melt lead, hot enough to destroy most materials we use on Earth. And the pressure was crushing, more than 90 times Earth's atmospheric pressure, equivalent to being nearly a kilometer underwater. The first images sent back were eerie. Flat plains of rock, broken terrain, an orange sky pressing down from above. No movement, no life, just a still, suffocating world. And the longer we looked, the stranger it became, because Venus doesn't just have a thick atmosphere. It has one of the densest atmospheres in the entire solar system, made mostly of carbon dioxide, with clouds of sulfuric acid, layered thick enough to trap almost all heat. Sunlight enters, but it doesn't leave. On Earth, heat escapes back into space. Clouds form, rain falls, temperatures balance out. But on Venus, that system collapsed. The heat stayed. And the more it stayed, the worse it got. This is what scientists call a runaway greenhouse effect. But that phrase doesn't fully capture how extreme it really is, because once it starts, it feeds itself. More heat means more evaporation. More evaporation means more greenhouse gases. More greenhouse gases mean even more heat. A loop with no natural stop. And at some point in Venus's past, that loop went too far. Billions of years ago, Venus may have had liquid water. Not just small amounts, but entire oceans. If that's true, then Venus wasn't always a hellish world. It may have once looked a lot like Earth. Clouds, rain, oceans, maybe even stable conditions for millions of years. But then something changed. As the sun slowly grew brighter over time, Venus received more energy. Temperatures began to rise. Water started to evaporate. At first, it may not have seemed like much, just slightly warmer, slightly wetter atmosphere. But water vapor is a powerful greenhouse gas, and as more of it entered the atmosphere, it trapped more heat, which caused more evaporation, which trapped even more heat. And just like that, the cycle began. The oceans didn't disappear overnight. They slowly boiled away, rising into the sky, filling the atmosphere with steam, until eventually there were no oceans left. And then came a critical moment, one that sealed Venus's fate. High above the planet, ultraviolet radiation from the sun began breaking apart water molecules. Hydrogen escaped into space, oxygen reacted with rocks below, and over time, Venus lost its water completely. No oceans, no rain, no way to cool itself. From that point on, the runaway greenhouse effect became permanent. But Venus didn't just stop there, because beneath its thick clouds, the planet is still active. Radar scans of the surface reveal vast volcanic regions, vast lava plains stretching for thousands of kilometers, massive shield volcanoes, collapsed structures. Some areas appear relatively young, too young, which suggests that Venus may still be volcanically active today, not constantly erupting like Io, but slowly reshaping itself over time. There is even evidence that the entire surface of Venus may have been resurfaced in the past, as if the planet reset itself, covering old terrain with new lava, again and again. A planet that doesn't just trap heat, but rebuilds itself. And then, there's one of the most controversial discoveries of all. In recent years, scientists detected traces of a gas in Venus's atmosphere, phosphine. On Earth, phosphine is associated with life, produced by microbes in low-oxygen environments. Its presence on Venus was unexpected, difficult to explain. Some scientists argue it could be the result of unknown chemical processes. Others say the detection might be incorrect. But if it's real, then something strange is happening in Venus's atmosphere. Not on the surface, that's too hostile, but higher up, where temperatures are cooler, where pressure is closer to Earth's. A thin layer, suspended between extremes. Could anything survive there? Right now, we don't know. And that uncertainty is what makes Venus so fascinating. Because for a long time, we thought we understood it. A dead planet, overheated, unchanging. But the more we study it, the more we realize it's not that simple. Venus is a world that changed dramatically, a world that crossed a line and never came back. And that makes it more than just a planet. It makes it a warning. Because the processes that transformed Venus aren't unique. They're based on physics, atmospheric chemistry, energy balance, the same laws that apply everywhere, including Earth. Right now, our planet is stable, balanced, habitable. But that balance is delicate. Venus shows us what happens when it breaks. Not instantly, not with an explosion, but slowly, step by step, until the change becomes irreversible. Venus should have been Earth's twin. Instead, it became its opposite. And the most unsettling part is this. It didn't happen because of one single event. It happened because of a chain of small changes that kept building until there was no way back. And once that line was crossed, the planet was never the same again.